Hi guys, my name is Cash and welcome back to another episode of 2Broke2Boosted, my budget turbo Miata project here on CashedOutCars. So in this video, we're going to be going over vacuum line routing on a turbo Miata and also oil line routing because someone specifically asked about that. So we're going to be going over that in this video too. So this will help you learn where to run all your vacuum lines in order to get your turbo setup running properly, where to route your oil lines to make sure that everything goes good with your turbo and that is properly lubricated, and basically just put these final touches on your turbo project to make sure that everything goes great with it once you're ready to start it up and drive with it. So let's get into it. So to start out, let's talk about the vacuum lines. So this car runs on a standalone ECU that uses the speed density principle, meaning that one of the inputs for the ECU that you absolutely need is the manifold air pressure. Now that's this vacuum line that runs here, and that runs off of the intake manifold after the throttle body to the ECU, which has a built-in onboard MAP sensor or manifold air pressure. Now, the manifold air pressure sensor tells the ECU what the engine load is, and that combined with the RPM tells your ECU how much fuel it needs to dump at specific loads and RPMs and what your ignition time is going to need to be. So this takes care of figuring out the pressure in the manifold, and the other sensor is RPM, but that's stock on one of these Miatas, and that runs right to the ECU. The other line that I have teed off of the intake manifold here runs to my blow-off valve. Now, if you're running low boost, you really don't need a blow-off valve. And even if you're running higher boost, if you want to get that compressor surge and get the turbo noise that a lot of people really like, you don't need a blow-off valve. But I like the sound of a blow-off valve, and it also prevents compressor surge and damage, so I'm running one. Anyway, once again, that gets referenced right to the intake manifold, and that will tell your blow-off valve when to open and relieve pressure from your intercooler piping. Next up over here, we have the vacuum line for your wastegate actuator. Now, this is if you're running an internal wastegate, which I am on my turbo because generally they're a lot cheaper and easier to set up than an external wastegate. If you're interested on the comparison between them, check out my channel. I have a video on that. But anyway, you need a vacuum line that runs from your wastegate actuator to somewhere fairly close to the compressor housing of your turbo. Now, you want to get that close to your compressor housing because that's going to give you the best signal. With these rubber lines, if you run a long signal, they could expand and contract under boost and vacuum and not really give you the best, most direct signal to your wastegate actuator. Now, if you do that, it just means that your wastegate actuator could be a little bit lazy and open up a little later than you want it to, which means you could end up over boosting and just having bad wastegate response if you're not careful with it. So with mine, I ran it right to the intercooler piping, close to the compressor housing of the turbo because I didn't want to tap the compressor housing of the turbo, and that's been working pretty great. There are two more vacuum lines that I want to talk about in this video, and one of those is the PCV Valve vacuum line. Now that runs right from the intake manifold to your valve cover, and you have your PCV valve there. So what this is basically a check valve. So when there's positive pressure in your valve cover, oil vapor and the extra pressure could escape into your intake manifold and you don't blow out seals in your engine. Now, it's a very good idea to upgrade your PCV valve on a turbocharged Miata. The reason for that is a stock PCV valve on a Miata is not made for boost, which means when you hit boost and there's positive pressure in this intake manifold, you could actually blow out your PCV valve and have the internals of that valve go into your engine. So a common upgrade for this is putting a Mazda 323 turbo valve in, and that is made for boost and it does a better job than a stock Miata valve. Now, you don't absolutely have to upgrade it, especially if you're running at low levels of boost, but for the extra piece of mind and a couple of bucks, I upgraded mine, and that's been great so far. Last on the vacuum lines for a turbo Miata is this vent right here that comes off of your valve cover. Now, you'll note that I do not have any vacuum line running off of this at the moment. What you want to do with this vacuum line is run it to your intake before the turbo. You want to run it there because at all points of driving, you're going to be pulling a vacuum at your intake because you're pulling air into your engine, into your turbo, and basically feeding the engine air through that. That means that you're always going to be pulling positive pressure from your valve cover, and that is good because you want to get that positive pressure out once again so you don't blow out seals prematurely and cause problems with your engine. Now on my car, I've been running pretty low boost and just running this thing to atmosphere, which has worked pretty decent. Now, if you do not have a standalone ECU and you went with the Car Passion channel's broken boosted method, which is still using the airflow meter, you absolutely need to run this to your intake, because if you don't, you could get unmetered air running into this and throwing off your engine. If you have an aftermarket ECU, it's not quite as much of a problem, but it's still a good idea to run that to your intake manifold to, one, catch oil vapor, it's better for the environment, and two, just make sure that no air is feeding in here, burning in your engine, rather than creating pressure at your intake manifold. With that said, once again, I've been running mine with no line on it, and that's because there's no easy way to run it to this cone filter just yet, and I haven't had any problems tuning the car with seals blowing out or with the car running poorly in general. But do keep that in mind depending on how you turboed your car. One more that I forgot that I was going to mention is the idle air control valve hose. Now this runs right to your intake, and on idle that valve opens and closes to allow more or less air to go into the engine and allow it to run right. Now, if you are still running an idle air control valve, which I would highly recommend doing, especially as a beginner tuner, you want to run that right to your intake piping. Now, in my case, that's right to my intercooler piping because, well, the car is turboed, but if you do an aftermarket ECU setup on a naturally aspirated car, you still want to run this right to your intake piping because that's where it wants to draw air from. And now we could get into the oil lines. So with a turbo, you need to feed it oil in order to keep it properly lubricated. This runs through your bearing, whether it be a ball bearing or a journal bearing, and basically keeps the thing moving smoothly in there without creating premature wear or excess heat, and it just keeps everything going as it should. Now, to run an oil line to your turbo, you need a source for your oil. On a 1.6 liter Miata, down there it's kind of hard to see, but this hose runs directly to a high pressure oil port that is left in the block. On a 1.6 liter, you just need to take a screw out, put your oil line there, and you have a high pressure oil feed that runs up to the top of your turbo. On a 1.8, it's slightly different, and you'll need to tee off somewhere in your oil system. A lot of people tee off the oil pressure sensor, and that's another way to get high pressure oil to your turbo. Now, you will want to run a restrictor to your turbo, and that will be depending on what turbo you're running. And the reason you want to do that is if you get too much high pressure oil running through your turbo, you could blow out your seals, your turbo will smoke, and you'll basically be burning off oil while you drive around with your car. The oil feed always needs to be at the top of your turbo cartridge in the middle there, and the oil drain directly on the bottom. This is because the oil feed and oil drain are gravity fed once they get to the turbo, and you want everything to drain out efficiently. I have another video on clocking a turbo in order to get the feed up top and the drain at the bottom, so if you're interested in that, definitely check it out. Next up, we move to the drain, which comes out the bottom of the turbo down there. Those are those anodized fittings that you see right there. This runs out the bottom of your turbo. Now, this is a much bigger line because the oil that comes out the bottom of your turbo is frothy rather than a straight up liquid like comes in, and there's air in it. So you need a bigger line in order to make sure that that drains straight down efficiently and effectively. Now, that oil that comes out of the bottom of the turbo needs somewhere to go. So that drain on pretty much all turbocharged setups that are aftermarket run back to the oil pan. Now, I'll go down below to show you what that looks like, but basically you need to drill a hole in your oil pan where that oil could go. This gets your oil back to the pan and the pickup where it could be picked up and recirculated back through the engine. So it's pretty simple routing for the oil lines on the turbo. You need one line in that's high pressure with a restrictor, and one line out that gets the oil back to your engine. And that's it for vacuum lines and oil lines. Other things that I quickly want to talk about in this video are sensors. So on a car that is tuned with the speed density principle, you often want to use an intake air temperature sensor. Now what this does is allow the ECU to correct for hotter or cooler air. With cooler air, you could burn more fuel because there's more oxygen in it. With hotter air, you need a little bit less fuel, and that helps correct for how much fuel goes into your ECU. Now, depending on what ECU you have, you might be able to have different spark settings for hotter air to help prevent knock and advance your timing a bit more for cooler air to get more power out of the car. To be honest, I have no idea if you could do that with a speedy EFI ECU, but you could do that to increase power or keep your engine safe depending on what ECU you have. So that's one of the main sensors that's used with this. The other input, like I said, is RPM, which is a stock input for the stock ECU. And the final thing for a sensor on this aftermarket ECU setup is this throttle position sensor. Now, this tells the ECU how open the throttle is and allows it to compensate for one, tip in, which is when you first get on the throttle. It could dump a little bit of extra fuel before the pressure really spikes in the intake manifold. And there are just a bunch of other little settings and tweaks that you could hone in with a throttle position sensor. One of those is launch control and flat foot shifting, which is super fun to play with, but there's a lot more that you could get out of these sensors. And so guys, I know that wasn't the most exciting video, but I hope it taught you something. That should have taught you everything you need to know about vacuum lines on a turbo Miata and really turbo cars in general, and the same thing with oil lines for your turbo. Don't forget to like this video if you enjoyed it and subscribe for more. If you want to see all the Cashed Out Cars content early along with sneak previews, check out my Patreon page and go support the channel there. And I hope you stick around for the next one. Take care.